Hi, welcome back to Moose in Chemistry. This is electron configuration of chlorine lesson. So chlorine is the 17th element on the periodic table. So we're going to put a 17 right here, and we're going to put a 35 right there for its atomic mass. Since chlorine is the 17th element, that means it has 17 protons, and since it's electrically neutral, it has to have 17 electrons. What about the number of neutrons? Well, you go A and U minus the number of protons equals the number of neutrons. So that would give me 35 minus 17, which would give me 18 neutrons. Pretty darn snarly. All right, now before we do electron configuration, it's important to remember that S has 2 electrons, P can hold up to 6 electrons, B can hold up to 10 electrons, F can hold up to 14 electrons. And we're going to use something called the diagonal rule, which means we're going to follow these red arrows through these marks until we run out of electrons. So let's see here. Let's go ahead and start. So we go 1s, 2. So we used up 2 electrons. 2s2. We used up 2 more electrons. 2p6, 3s2. So 2p6, 3s2. And now we can come back to 3p5. So now if we count those electrons, it makes 17 electrons. All right, now let's look at orbital notation, which involves Hund's rule. Hund's rule says that for every suborbit, you have to put the first arrow up before you can begin the second arrow. So 1s, we go up and then down. And then 2s, we go up and then we go down. Now 2px, 1, 2py, 2, 2pz, there's 3. Then we start over, 4, 5, and 6. Pretty easy, huh? It really is. So let's go to 3s, up arrow, and then down arrow. Now let's look at 3p. We got 5 of those. So go 1, 2, 3. Now we start at down arrows, 4, and 5. Pretty darn snarly. Now what about our noble gas notation? Well, you would be tempted to say, hey, what about argon? That's closer to chlorine than any other noble gas. But you would be wrong to say that. You can't use argon because it comes after chlorine. So we're going to use neon. So we're going to write neon in here. And now we're going to look at the valence shell. The valence shell is the last shell of electrons, and that's this right here. This is our valence shell. So we're going to write 3s2, 3p5. Pretty darn snarly. By the way, snarly is the cool. Now, let's look at our quantum numbers. Let's look at our principal quantum number first. What period is chlorine in? Well, chlorine happens to be in the 3rd period, right? So our quantum number for the principal number is going to be 3. So we're going to put a 3 there. It happens to be also in the p block. Matter of fact, it's all the way over the p block just about. So our L value, our angular momentum number, is going to be 1. Our magnetic number, remember we repeat this pattern, -1, 0, 1, -1, 0. So chlorine is going to be 0 for the magnetic number. So we're going to put that 0 right there. Okay, let's look at our last arrow. Our last arrow right here is going down, right? So that's going to be, for our S value, is going to be 1/2 negative. Well, that's it. You guys be snarly, and we'll see you back here at Moose in Chemistry.